Hello everyone and welcome to another Motec webinar. My name's Mark McCoy and I'll be your webinar host for today. Today's subject is how to calibrate ECU sensors. Just getting started, I'll basically explain what a calibration is and effectively where you set the calibration and the difference between a few different methods of calibrating sensors into the ECU. So some of this will apply to the dash loggers as well, but probably more just a bit of general information on how Motec treats sensors and their calibrations. There are a couple of different sort of types of sensors that we'll go through. One will be like our normal analog type of sensors, which is say engine temp and air temp, and also I've got a specific bit on wheel speed calibrations because they're a little bit different. Firstly, what is a calibration? The ECU inputs are basically like a high-speed, high-accuracy multimeter. So it pretty much just reads voltage from the sensor. Now, obviously, for us as users, I don't want to see a map sensor that reads 0.38 volts. I want that 0.38 volts to be something relevant to the engine I'm tuning. So in the case of the map sensor I have pictured there, we can the actual calibration would be saying that the 0.38 volts equals 150 kPa. So from the sensor's point of view and then the ECU's point of view, it sees 0.385 volts. From our point of view, tuning this engine, we'll see 150 kPa. So it's basically a translation between the voltage from the sensor and translating that into something that's useful for us as the tuner. The calibration, like I said, here's a bit of a more of a diagrammatical sort of fashion of, we basically say each voltage equals a different reading. In this case, I've got a bit of a temperature graph here. That's mainly because a temperature sensor is a bit more interesting to look at. A manifold pressure sensor is usually a nice linear type of sensor where you only really need the highest point and the lowest point, and the ECU will draw a line straight in between. So we can sort of see here with my little red markings, we basically, the ECU gets a voltage and it uses this curve and gives us a reading out as the tuner. So then we can sort of make sense of what all these sensors are doing. Okay, they're also sometimes called a transfer function. So if you hear some of the factory engine calibration guys, they'll sort of refer to it as a transfer function. So just something if you hear it in conversation, really. So where do we need to set this? So just for the purpose of the webinar, I just usually sort of put up in the corner there, if I'm moving around the ECU software, I'll have a bit of a guide to what menu functions I'm using. So when I'm talking about sort of the menus, we're looking sort of up here. Usually when you click on adjust, it'll have a drop-down menu and we just sort of run to the side. And the one we're interested in today is the input setup. Now, this input setup, you can do this online, as in connected to ECU Live, or offline, simply sitting there with your laptop and OCR in sight. Either or, it will be fine. Obviously, if you do it offline, you'll need to then at some point send it to the ECU in the car. Once you click that input setup in the ECU manager, you'll come up with a screen that looks a bit like this. Now what this is a basic overall screen for the ECU inputs. Now you can see that we have quite a few different pages of different sort of sensor groups. So you've got access to all those sensor groups to be able to put a calibration in. Now just for today's example, I'm going to pick on the manifold pressure. So if we highlight that in blue, simply just clicking on it, and then we can either click the change button or simply double clicking that channel where the blue part is, that will do the same thing. Basically gives us a page like this. Now there's a lot of information about this channel. I'm going to basically go through all the little details. Just a couple of things I want you to notice at the top. For manifold pressure, at the top we've given this channel a name. That's fixed, so is the abbreviation. Some of the user channels, which are basically general purpose channels which have no specific name, you can change the name of those ones if you want. So moving on. The first thing we need to choose is the input source. Now what we mean by the input source is which pin is this sensor directly wired to. Now in this example I've got AV2, so that means it's directly wired into the AV2 pin on the ECU. Down that list, if anyone's interested to sort of look down there, you'll also notice that there's expander modules and also dashes and even second ECUs. We can actually grab these channels from a direct wired-in sensor or some CAN information that may be coming from our data logger, an expansion device, or even a second ECU. So this part here basically says to the ECU, where is this information coming from? The next part, and this part is relatively easy, we've provided some basic calibrations for specific sensors. Generally the ones we sell, we will do the calibration for the customer here and simply put them in the list. Just one thing to note is that for manifold pressure, we will only show the predefined calibrations for pressure sensors. Like obviously there's no point in displaying kilograms or percentage or something like that when it's a pressure channel. So in that list there will be all the Motec sort of known pressure sensors. So you simply pick the one that you want. Normally when you get the sensor there will be a listing of what calibration you need. Simply click on that. That's predefined. That will set the ECU up to use that pressure sensor. If we have a sensor that we haven't seen or used before, I mean that's not too much of a problem. You don't need that sensor and go out and buy one of our sensors. You can do what's called a custom calibration. So if we have a pressure sensor and it's maybe off a car that we have, it's quite a simple matter. What you're going to need to do is set this up as a custom calibration. You're still going to need your units. So you'll notice here I've highlighted in blue, I've chosen the KPA, so we'll keep things nice and simple and similar to what we do normally. But if you wanted to choose PSI, inches of mercury, or even bar for that matter, you've got options there. Next, once we've chosen a custom calibration, basically this says to the ECU that we as the tuner or the user want to enter in our own calibration. So by clicking on table, that will give us, surprisingly, you'll notice there's two lines to this table, voltage, and one's the actual KPA. So what we're going to do now is we're going to say X KPA, whether it be 100 kPa, 200 kPa, or whatever, equals what voltage. Now we here at Motec, just my picture down in the bottom corner there, that's like a calibrated pressure testing device that we use. It actually gives a readout for what pressure we have. So what we would do is, if you have a look where I have the highlighted value there, if we have that value highlighted and I've written in 200 kPa, if we set our pressure testing machine up to 200 kPa and then simply press the read value button, that will put the voltage that the ECU is currently seeing, in this case 4.5 volts, straight into the cell above 200. So then every time the ECU sees 4.5 volts, it's going to tell you as the tuner 200 kPa. And then what we do is we just go down and do a few points just so we know that we've got like the correct calibration. And as I said previously, with all the manifold pressure or pressure sensors I've seen so far, they're pretty much a linear sensor. So I only really need 2 of those 3 points to make the sensor read properly. Just for anyone who's got this in their mind, if I went to 200 and say 10 kPa, the ECU will extrapolate the information off each end of that scale, and more or less what will happen is it will keep reading above 200 kPa until it simply reads out a voltage, or that the sensor won't read any further. Same on the bottom end. Like at 20 kPa, if we went down to say 15 kPa, the voltage from the sensor would drop until it quite literally reaches its limit, and that's as far as we can go. So you don't need to specifically work out the exact voltage range of this sensor, as long as you've got somewhere in between. Mind you, while you're testing, you probably want a fair idea of where this sensor is going to run out. Basically, most automotive sensors will run to about 0.5 volts all the way up to 4.5 volts. Some of the sensors may, go a little bit more or a little bit less, but they will never go to a flat 0 volts, and they will never go to a flat 5 volt. They're just not made that way. Speed calibrations. Again, we need to just change where we are in software. So if you wanted to just run through, we're now in our digital inputs. The wheel speed is a digital input. Now, effectively what that means is, compared to a manifold pressure sensor, with manifold pressure, the voltage output varies. Now, with each, say, trigger on the trigger disc that's on the wheel of a wheel speed sensor, each trigger will give exactly the same voltage, but we keep getting pulses of the same voltage. So what the digital input is going to do is more or less measure the frequency or how many pulses we get per second, and make a calibration for wheel speed from there, rather than an absolute voltage. The most important thing here, and I'm only going to sort of mention enough to get this sort of sensor going, is the calibration. So instead of putting the calibration in directly into the input setup as we did for the manifold pressure sensor, we have to set this up in the digital inputs. Now, I've shown the maths down the bottom. The calibration basically equals the number of trigger teeth per 1 wheel revolution, and that's divided by the wheel rolling circumference in 10 kilometers, in kilometers, multiplied by 10. So if you do that little calculation and plonk the number in there, like maybe it's 220, that will then calibrate the wheel speed. So once you're moving at 10 kilometers an hour, the ECU will read 10 kilometers an hour. Now, just as an extra step that we need to put in the current versions of software, we more or less still need to go back into our input setup, the same as with the manifold pressure sensor. And now you can see in that list, I've clicked on the left drive speed, and I'm telling it, that is going into digital 1. But luckily for us, because we've calibrated this sensor in another spot, we can just simply say 1-to-1 calibration. We still need to choose our units though. So in this case, I'm just going to say it's kilometers per hour. So 1-to-1 tells the ECU, hey look, read whatever is calibrated in the other section of software and just use that number straight out. There's no modification to it. Now, that simply means that for wheel speed, we now have to do the input setup, but we also have to do the digital input setup. You have to do both, otherwise your wheel speeds won't work. So if you set this up and not the digital input, it's not going to work. If you set up the digital input as per our older 100 series ECU software and don't do this bit, it's not going to work. Do both parts. Now, just getting back to some of those extra details, we've already been through the name and the input source and the calibration. There's now a few extra details that we're able to use for each of the inputs that are quite important and quite handy. One is our default value. So I was saying before that the sensors never go to a complete 0 and they never go to a complete 5 volts. Basically, the way the sensors are manufactured is if they ever go to 0 volts or straight 5 volts. That's because they've failed. So what we do in the ECU is we sort of set an idea of, if this sensor fails, what value do you want the channel to read? Because obviously we don't want it to go to 0 or maybe the maximum value. But what we do is we sort of set, like, what would be the most appropriate value for the particular sensor if it failed. Now, just as a bit of an example here, manifold pressure. Let's consider this was a naturally aspirated car and it was mapped or tuned using our manifold pressure. If the driver didn't notice that there was something strange with the car, and we set a default value of, say, 30 kPa, if the guy's flat out, 100% throttle, the engine's actually getting 100 kPa, you'd probably want to err on the side of caution, where the engine's more likely to run at its wide open throttle state than try to fudge it and say that it's always at idle. So just pick your default values for taking into consideration, if this sensor fails, the driver's out on the track, he doesn't notice something, what's going to be the safest sort of default value for that particular sensor. So if it was a turbo car that went to a bar of boost, you'd probably have a default value of 200 kPa. Luckily in our software, as I said, some of the sensors, they might go to 0.5 volt and up to 4.5 volts, but some of them go a bit further than that. What we're actually able to do is, to decide on whether we need the default value or not, we can change the diagnostic low and diagnostic high. So effectively, you have the option to change the fault recognition voltages yourselves. Like some of the newer map sensors that General Motors are using will pull down to very, very low voltages, a lot further than they have before. So we had problems with earlier versions of software where the diagnostic values were fixed and the customer couldn't change them. So we thought in the current version what we'll do is we'll add these in, so even over the phone the customer can say, I'm having this problem, try a lower diagnostic value, and yep, the sensor doesn't go into fault anymore, works perfectly. Saves a lot of hassle, especially with some other sensors that might pull all the way up to nearly 5 volts as well. The filter. Now, the filter is there, well, quite literally to filter any noisy signals coming in. Now, just over to the left, I've basically done a quick bit of a diagram. Now, that's exactly the same signal into the ECU from the manifold pressure sensor. I've simply just doubled it up. Now, you can see the red one is a very low filter, so it reacts very fast. But if this sensor was in a manifold that had a lot of pulsations, I'd be getting a lot of bouncing around of that red signal. It becomes a little bit difficult to tune. So what you want to do is, in that case, you would just filter it a little bit, just so that the manifold pressure signal wasn't bouncing around so much that you were having problems tuning it. But if I go too far, as you see with the green trace, you'll notice that what would end up happening is I'd get rid of my pulsations, but you can see that the green one is lagging a long way behind the red one. Remember, they are the same signal. One of them has been heavily filtered. So if you heavily filtered the manifold pressure, and that's what you were tuning from, when you have sharp stabs of the throttle, the engine's going to hesitate because you have filtered the channel so much that it can't physically keep up, or the mathematical calculation has slowed that channel down and your tuning's not going to be very good. So filtering, realistically, you want to use the smallest number possible. In fact, you pretty much just leave them at their default unless you have a need specifically to go up. But again, a warning, just be careful of filtering things, especially if it's something used for engine control. If you go too far, filtering will always add some lag. Warnings. Okay, warnings, what we have is the ability for you to put up on your screen, let's say an example is a turbo engine. and we know it only wants to go to 220 kPa or 1.2 bar of boost. What we're sort of saying here is in the warning high, if we go up to 250 kPa, we want to know about it because that's outside the range of what we actually want to do. So we can set a 250 kPa warning. So you're doing a ramp run, say, you're expecting 1.2 bar of boost, the thing goes to 1.5 bar of boost, you get a big warning on your screen telling you that, hey, look, something is out of bounds here. It won't stop the engine, it won't put the sensor into an error, it's just simply warning you. Now, the one thing I will mention that you have to be a little bit careful of is the warning is a fairly important message, logically enough. Now, what it will do is the warning will come up in the middle of the screen and it will actually stop you tuning. So all the keyboard inputs stop working until you've cleared that warning. Like I said, it doesn't stop the engine, it won't cause any misfires or anything like this, it just simply gives you a warning. But if you're messing around with some fuel numbers during the ramp run and you get this warning, you're going to have to clear the warning before you continue tuning it. I won't say it's an annoyance, I'll say that's the way it's designed to work, but just be aware. So you might have to sort of get out of it and stop your ramp run. And if it's over a warning, you should really be checking that out before you continue with your tuning anyway. Okay, I hope that's been informative for you all. As with anything, webinars, these are all recorded, and what we do is we put that up on our webinar section on the website for you to download and view as many times as you want. Feel free to pass on the link to anyone you think could use the information, and also, as always, I would recommend that you join our Motec forum. If you need some help maybe on the weekend or after hours, and none of us are here because we're going home, you can put your question on the forum. There's usually plenty of people. It's a worldwide forum, so it means there's plenty of people around the world who are up at about the same time you are, so they will possibly be able to help. Again, thank you for attending, and I hope you can join us next time.